Well, welcome. I am Mr. Murphy, and you might remember me from the videos from Chapter 1, but I'm also going to be making the videos for this chapter in Chapter 3. So in this first lesson, we're going to be looking at graphing polynomial functions, and specifically in this first video, we're going to be looking at how you can predict the behavior of polynomial functions, and specifically the end, what we call the end behavior of the function. But to start out with, let's do this warm-up activity. So here we have these three functions, and I want you to identify the number of terms in each expression, and the degree of each expression is already in red for you. Now you don't know what that term degree means yet. That's what we're going to be talking about next. But I want you to see if you can make what we call a conjecture, which is like a rule about the degree of any polynomial expression. So I want you to look at, so first you're going to look at how many terms there are for each of those. But then I want you to look at the polynomial itself and the degree, and I want you to see if you can make a connection between those two. So why don't you pause the video and go ahead and see if you can identify those different features. All right, well, what did you come up with? Well, first off, that first polynomial has three terms, so a term is separated by a plus or minus. So in that one there we have three terms. The next one, we have five terms. Because, again, you look at each individual piece that's separated by a plus or minus. So that one would have five terms. And the last one would have four terms. So as you can see, there's not a connection between the number of terms and the degree of the polynomial. So did you, or were you able to come up with a connection between those two? Maybe you came up with something like this. If you notice, the largest exponent for each polynomial was the degree of the polynomial. And so we're going to get that in our notes in just a second. So we need to identify some different terms that we're going to be using in this unit. So first off, it says here in this example, it says, how can you write a polynomial in standard form and use it to identify the leading coefficient, the degree, and the number of terms? So recall that a polynomial is a monomial, or the sum of one or more monomials, called terms. The degree of a term with one variable is the exponent of that variable. Okay, so that's just referring to identifying what a polynomial is. So basically a polynomial is made up of a bunch of monomials. Monomials is just where we have one term. And the degree of a single term with a variable, okay, so we get degrees from the variables, not from just plain old numbers, but we get degrees from the variables. So the degree from one term with the variable is the exponent of that variable. And I'll identify the key things as far as what you want to write down. So for this example here, the degree of negative 4x would just be 1. If we were to look at the degree of 9, the degree of that would be 0, because there is no variable. Okay, so we only get actual numbers for our degrees from variables. If there is no variable, the degree is 0. The degree of the 2x cubed term would be 3. So the leading coefficient, okay, so this is a term you do want to write down. The leading coefficient refers to what we call the non-zero factor that is multiplied by the greatest power of x. Okay, so the leading coefficient of this polynomial is going to be 2. So what does that mean in general terms? So in just common terms, the leading coefficient, okay, so let's break that down. Coefficient is always the number that's attached to a variable. Okay, so looking at that original polynomial, the leading coefficient of that first term would be negative 4. I'm sorry, the coefficient, not the leading coefficient. The coefficient of negative 4x is negative 4. The coefficient of 2x cubed would be 2. So we want to identify what we would call the leading coefficient. So the leading coefficient would be the coefficient that's attached to the variable with the largest exponent. I'll say that again. That might be the way that you might want to write this down in your notes. The leading coefficient is a coefficient attached to the variable with the largest exponent. So that's what we would call the leading coefficient. When we put something in standard form, which we're going to talk about in a minute, the leading coefficient then would go first. So again, this polynomial has three terms, so it would be called what we call a trinomial. If you think about a tricycle has three wheels, a trinomial has three terms. So we name a trinomial based on the number of terms it has. So a binomial would have two terms, like a bicycle has two wheels. The degree of a polynomial is, this is what we were talking about in that warm-up. but the degree of a polynomial is the greatest degree of any of the terms. Okay, so that's kind of like how we phrased it earlier on. So this is, and I would write that down. So we've talked about a couple of key terms here. So the first key term is a leading coefficient. The second key term is the degrees. You want to make sure you get this written down. That the degree of a polynomial is the greatest degree of any of the terms. And so in this example, the degree would be 3. And so this would also be known as a cubic polynomial. Okay, so it's based on the number of terms, it's a trinomial. Based on the degree, it would be called a cubic polynomial. So let's talk about the standard form. Okay, so you need to be familiar with that. Now last chapter, when we were dealing with quadratics, we had the standard form of a parabola. If you remember, that was ax squared plus bx plus c. So standard form of any polynomial, basically what you're going to do is you're going to start with the largest exponent. So you're going to start where the term with the degree of the polynomial, and then you're going to go in descending order with the exponents. Okay, so we would start out with, in this case here, we would start out with the largest exponent is a 3. So the degree of the polynomial is a 3. So we would start out with that term. So we would start out with a 2x cubed. Now if there had been a term here that would have a square as an exponent, that would come second. But we don't have that. So there's no x squareds here. But then the next largest, going in descending order, would be the negative 4x, because that has a degree of 1, and the 9 has a degree of 0. So when we put it in standard form, we're putting it in descending order of the degree of each term. All right, so here's what I want you to do. We're going to do this first one together. It says, what is each polynomial in standard form, and what are the leading coefficient, the degree, and the number of terms of each. So we'll go through this first one together, but I want you to try the next one on your own. So for this one, the first step is to put it in standard form. So again, for standard form, we're going to start with the term with the largest exponent. So as I look at those four, the term with the largest exponent is the negative 3x to the fourth power. So we're going to start there. And then we're going to go in descending order. So we would go, if there's one with a cube, which we do, then we would go with a square. There's no square, so we would skip that one. Then we'd go x to the first, and then we'd go down where we don't have an x. So in standard form, this would be negative 3x to the fourth minus 5x cubed plus 2x plus 6. You want to make sure that as we're putting this in the right order, that you're taking with it the sign that's in front of each of those terms. So that 3x to the fourth, there's a minus in front of it. So that's a negative 3x to the fourth. That is really important. You don't make that mistake. Then, like I said, follow with minus 5x cubed, then the 2x, then the 6. All right, so the next thing it asks for is, what is the leading coefficient? The leading coefficient then would be so this is supposed to be a negative 3. So let me write that in there. It's supposed to be a negative 3, so there's a typo there. So the leading coefficient would be negative 3. The degree would be 4, so the largest exponent would be 4. And the number of terms are 4 individual terms there. All right, so I want you guys to go ahead and try the next one on your own. So I want you to start by putting it into standard form, and then find the leading coefficient, and then find the degree and the number of terms the polynomial has. So go ahead and pause this video so you have an opportunity to try that on your own. All right, let's see how you did. So first off, this is a much larger polynomial, but you look at that, the largest exponent is a 6. So that's where we'd start. So we'd have the 2x to the 6, that's positive, so it'd be just a positive 2x to the 6. Then we have x to the 5th. X to the 5th is positive, so we'd write plus x to the 5th. And then the negative 3x to the 4th, so minus 3x to the 4th. Then we'd have the 4x cubed, so plus 4x cubed, and then minus 8x. And there are no just plain old numbers without a variable. So that's where we'd end at. All right, so now let's look at the leading coefficient. So just as a reminder, the leading coefficient is referring to the coefficient, so there's no variable attached to it. So do not say the leading coefficient is 2x to the 6th. Okay, the coefficient is just the number, so it would just be just the 2 there. Okay, so then the degree of this polynomial would be 6, and the number of terms this polynomial has is 5. All right, so the next thing we need to focus on is kind of the key part of this lesson. So not only do we have all those individual terms that you need to be familiar with, but we need to talk about what's called the AND behavior of the polynomial. And the reason why this is so important is this is going to allow us to have an idea of what the graph is going to look like without actually seeing the graph. without having to pull out a graphing calculator and looking at it. But we are, for the purpose of understanding these, we're going to start by looking at some graphs. But like I said, we're going to take away from this being able to figure out what the end behavior, what the graph would look like without actually having to graph it out. So let's start with odd degrees. So odd degrees would be degrees like 1, where the polynomial would have a degree of 1, 3, 5, 7, 9, and so on, with a positive leading coefficient. So here's a few examples. So here we have f of x equals x. That's just a linear equation. So the degree of that is 1. Notice the a value for that is positive. And you can look at that red graph is increasing from left to right. Okay, so the right side of the graph is going up, the left side of the graph is going down. Look at the blue graph. The blue graph is the graph of 1/2 x cubed minus x squared plus 3. So in that one, the degree is 3. So another odd degree there. And notice the a value is 0.5. So the leading, when I say a value, I'm referring to the leading coefficient. The leading coefficient there is positive. It's positive 0.5. And that graph is also going up on the right and going down on the left. Okay, that's significant. The next one there, the one in green. The one in green has a degree of 5. So again, it's an odd degree. And the leading coefficient there is 2, so it's positive. And the degree there, or the graph there, the green graph, the right side of the graph is going up, the left side of the graph is going down. So there's a common theme there. Notice a common theme there is with when the exponent was odd and the leading coefficient was positive. So the way that we can describe that is this. So down in the below there we have as x approach, the way that we read that, the arrow there means approaches. Okay, so when you write this down in your notes, so as far as what you want to write down right now in your notes on this slide is if you don't have my notes or these notes printed out, you can sketch those graphs. They don't have to be perfect for those 3 graphs. And then right below there, you want to make sure that you write down these 2 phrases. X with an arrow pointing to positive infinity, comma, y with an arrow pointing to positive infinity as well. Well, what does that mean? Okay, that arrow means, like I said earlier, the word approaches. So what you want to do in your notes is you want to put the word approaches there. So I'll do the same. Whoops. Okay, so when you see that arrow, it means the term approaches. So we would read that as x approaches infinity. Well, that's also referring to the right side of the graph. Okay, so when we talk about as x approaches infinity, I want you to remember that that's referring to the right side of the graph. Well, what's happening to y? So as x approaches infinity, y is also approaching infinity. So y is going upwards. So the right side of the graph, as x approaches infinity, the y values are approaching infinity as well. So the y values are going up. That's how we're going to refer to it. And that's true for all 3 of those graphs that we just looked at. Let's look at the other part. As x approaches negative infinity. As x approaches negative infinity, y is also approaching negative infinity. So y is going down. So as x approaches positive infinity, that's referring to the right side of the graph. As x approaches negative infinity, that's referring to the left side of the graph. So that might also be useful information to put down in your notes. Now I want you to identify too the fact that here we have arrows on both ends. And so whenever we have an arrow on the graph, we're going to have end behavior. Okay, so in this case we have 2 arrows, so we're going to have 2 end behaviors. One for the right side of the graph, one for the left side of the graph. So the right side of the graph, remember, is as x approaches positive infinity. The left side of the graph is as x approaches negative infinity. Well, what if we're dealing with even degrees? So all of those are dealing with odd degrees. Now let's look at what happens when we deal with an even degree. So even degrees would be where we have a degree of 2, 4, 6, 8, and so on. And again, we're only dealing with positive leading coefficients. So here we have an x squared, so the degree is 2. And if you notice that, again, the right side of the graph is going up, but this time the left side of the graph is also going up. And the next one here, we have 0.9x to the 4th minus 2x cubed, and so on. So that one, the degree for that one is 4. So again, an even degree, and our leading coefficient is positive. So notice the right side of the graph is going up for the blue graph, but the left side of the graph is also going up. So again, we're looking for similarities here between these graphs. For the one in green, the one in green has a degree of 6, so again, another even degree. And our leading coefficient, again, is positive. So notice there that both ends of the green graph are also pointing upwards. So let's see what we can take away from this. So here we have a positive value for our leading coefficient, and it's going up on the right. And here we have an even degree, and both sides are going the same direction. Okay, so here's how we're going to describe this. Again, same thing is true. That arrow means the word approaches, and as x approaches positive infinity, that's referring to the right side of the graph. As x approaches negative infinity, that's referring to the left side of the graph. And so for all of these graphs, as x approached infinity, y also approached infinity. And as x approached negative infinity, y approached positive infinity. Okay, so both sides of the graph went up. So here's some hand motions that are going to make this useful, because you're probably wondering, okay, I see this, but I'm not quite getting what I'm supposed to be taking away here. Here's what I do. The right side of the graph is determined by if the leading coefficient is positive or negative. We haven't talked about negative yet, okay, but we're going to see that in a second. But let's just identify what we're seeing here. So when our leading coefficient was positive, the right side of the graph is going upwards. When the degree was odd, the left side of the graph went in the opposite direction. So if the right side of the graph is positive, so if our leading coefficient is positive, the right side of the graph is going to go up. If the degree is odd, the left side of the graph is going to go down. See that? Look at the second set of graphs. The leading coefficient is positive, so the right side of the graph goes up, but the degree is even, so they both go the same direction. Okay, so maybe this is starting to click, maybe not. It's okay. Let's look at the next slide and see what happens when we have the leading coefficient being negative. So again, this is that just summarizes what we were just talking about here. All right, so let's look at this next one. So again, this is dealing with an odd degree. Notice what happened with these graphs. They just flipped. Okay, so here we have the same graphs, except for now they're just flipping. So instead of going up and to the right, they're going to go down to the left. Okay, or down and to the right instead of going up. So for the first one, again, the leading coefficient here is negative. So that means now that's going to be, so the right side of the graph is going down. And all of those, the leading coefficient are negative. Okay, and the right side of the graph for all of those are going down. And the left side of the graph now is going up. They're going in opposite directions. So let's make that connection with what my hand motions that I was doing earlier. So if the leading coefficient is negative, the right side of the graph is going down. And if the degree is odd, they go in opposite directions. Okay, so when the degree is odd, they do opposite directions. Odd, opposite. Easy way to remember that. Okay, so how does that affect then the end behavior? So the way we describe the end behavior is we would say then as x approaches infinity, y approaches negative infinity for these. As x approaches negative infinity, so the left side of the graph, y is going to approach positive infinity, is the way we describe that. Okay, let's look at if it's an even degree. So if it's an even degree, remember that means they're going to go the same direction. But because our leading coefficient is negative, they're both going to be going down. So we describe this end behavior. So for the right side of the graph, as x approaches infinity, the end behavior is going to be going down. For the left side of the graph, as x approaches negative infinity, it's also going to be going down. So it's going to be approaching, y is also going to be approaching negative infinity. So let's look at an example together. So this one, it says, use a leading coefficient, degree of the polynomial, to determine the end behavior of each graph. Okay, so for this one, the first thing I want to look for is it in standard form? This is already in standard form. So what we're going to do is we're going to identify two things. Is the leading coefficient, is it positive or negative? And also, is the degree of the polynomial even or odd? Okay, so this time I notice that the leading coefficient is positive. So the right side of the graph is going to be going up. Okay, so the right side of the graph is going to go up because the leading coefficient is positive. The degree is 6. So the left side of the graph is also going to go up. Okay, so if we think about having two blanks as far as the left and right side of the graph, we always start with the right side first, because that's going to determine what the left side is going to do. So the right side of the graph is going up because the leading coefficient is positive, and the left side of the graph is also going to go up because it's an even degree. So it's an even degree with positive leading coefficient. So here's how we can describe it. As x approaches positive infinity. So that is referring to that part of our graph. As x approaches positive infinity, the y values are also approaching infinity, positive infinity. This piece here is referring to the left side of our graph. So the left side of our graph is as x approaches negative infinity, y is also approaching positive infinity. Okay, let's look at the next one together. Okay, because I think for these, it would be good for us to look at both of these together. So for this one, again, we have it in standard form. It's always the first thing you look for. Is it in standard form? If it's not in standard form, we want to get it in standard form. So it's in standard form. And this one, we notice our a value is negative, and we're dealing with an odd exponent, so an odd degree. So what does that mean? So again, I would put down two blanks here if I was doing this on my own. And then I'd write down, okay, what's happening on so the second blank is referring to the right side of the graph. What's happening on the right side of the graph? The leading coefficient is negative, so the right side of the graph is going to go down. Okay, the degree for this is going to determine what's going to happen on the left side of the graph. So the left side of the graph is odd. So what does that mean? Odd opposite. So they're going to go in opposite directions. Okay, so then we would have the left side of the graph would go up. So the way we would describe this is, again, the right side of the graph is going down. So we would say as x approaches positive infinity, y is going to approach negative infinity. And the left side of the graph is going to be as x approaches negative infinity, it's going up. So we would say y approaches positive infinity. So hopefully you see how that works. I want you to try one on your own. Now notice before you start this one, notice that this one is not in standard form. So before you start, you need to get this in standard form. So this is good practice from what we did at the beginning of the lesson. Okay, to tie this all together. So I want you to start by getting this one in standard form, and then I want you to figure out, is it what's going to happen with the end behavior? So is the graph going to increase from left to right? So is the right side of the graph going to be going up, or is the right side of the graph going to be going down? And then as far as the degree of the polynomial, is it odd or even? So is the left side of the graph going to also be going up or down, or how's that going to look? So I want you to try this one completely on your own. So pause the video and hit play when you're ready to check to see if you've done it correctly. All right, so let's see if you did this correctly. So let's start getting it into standard form. So we would have it negative 3x to the fifth plus x to the fourth minus 2x cubed plus 3x squared minus 14x minus 5. Whew, a lot of terms there. Okay, so just to review, this one has 6 terms. So now we want to figure out what's the end behavior going to look like. So first off, you should have recognized that the leading coefficient is negative. It's a negative 3, and the degree is 5. Okay, so you might have done something like this with your blanks and saying that, all right, the leading coefficient is negative, so the right side of the graph is going to go down. The degree is 5, so it's odd, so it's going to go in the opposite direction. So the left side of the graph is going to go up. So that's what they're saying there. Move that out of the way. So this is an odd function, so the function will increase infinitely as x decreases, and decreases infinitely as x increases. So the way we would describe this is we would say as x approaches positive infinity, so the right side of the graph, remember here we had the right side of the graph is going to go down, the left side of the graph is going to go up. So we would say as x approaches positive infinity, y is going to approach negative infinity. And then we would say as x approaches negative infinity, so that's referring to the left side of the graph, y is going to approach positive infinity. So that's how you'd write it out with symbols. What is there down there, that would just be in words. But you need to be familiar with writing that in symbols. So hopefully all of that makes sense. And that is where we're going to end this first part of the lesson.